Hello everyone, welcome back to another very interesting question, beautiful conceptual question, proper IIT JEE advanced level and requirement. About 3 concepts are there. I hope all of you are comfortable with these concepts. Hope that we'll revise those concepts using this question. This is taken again from Pathfinder, Build Your Understanding question number 13 from System of Particles. A small block A, this is A, of mass small m equal to 2 kg sliding on a platform lands, this is a platform you have, lands on a cart B of mass capital M, this is cart B of mass capital M 8 kg that is placed on a frictionless horizontal floor. So this is frictionless. Okay. The distance between the left end of the cart and an obstruction at the right end, you see this is, there is a protrusion up there. So that is at a distance L from the left end. Okay. The coefficient of friction between the cart and the block is mu equal to 0.5. So there is friction between block and the cart, but not elsewhere. Okay. And the collision between the block and the obstruction is perfectly elastic. Okay. So collision is elastic here. Between A and this B right end is going to have a collision there. The speed with which the block lands on the cart is so adjusted that the block stops on the cart. Block stops on the cart meaning with respect to cart it will come to rest, not with respect to ground. That's a meaning you should take. At the rear end, so you have to project it in such a way that as it enters in, of course the platform also moves, the cart will also move, but relative velocity of A would be forward and collides with this right end, and relative velocity will be backward after that, and then finally when it comes to this rear end it will have 0 relative velocity, and that's how we are going to adjust the initial velocity. Okay, now the question would be, find the time spent by the block on the cart. So how much time it is spent on the cart, that is one, and the second one is loss of mechanical energy during this time. So these are the 2 questions we have. Let us try to understand it. Okay, first concept, work done by internal kinetic friction. So when we say internal force, right, the system should contain both action and reaction, then we call that as force as internal force. Okay. So work done by internal kinetic friction meaning work done by action plus work done by reaction together equals to minus of Fk into S relative. So if I take block and this platform or the cart together as a system, the kinetic friction, action and reaction are within the system. So net work done by that, work done by friction on the block and also work done by friction on the cart together will be equal to minus of Fk into S relative. And here during the forward journey relative motion, you see that S relative is forward, kinetic friction is backward. So it is going to be having negative work done. During reverse relative motion, relative velocity is backward, relative displacement is backward, but kinetic friction will be forward there. Again it is going to be opposite. And so work done by friction, if you are calculating it during the entire journey, it will be minus Fk into L plus L, 2L you should write. That's what I had written here, Fk into L plus L, 2L. And also loss in mechanical energy here is happening only because of the dissipative force, and that is the internal kinetic friction. So loss in mechanical energy equal to negative of work done by that dissipative force. So you get that as Fk into L during the forward journey of relative motion, and again twice of it will give you the total backward and forward together. So 2 into mu into mg normal reaction into L. So mu they had given 0.5 into 2 is 1, m is 2 kg, g is 10, we are assuming 10, they have not given, but I am taking it as 10 here. L is 1 meter, so 20 joule is the loss in mechanical energy. So that is the first concept, very simple. The next concept would be loss in kinetic energy when our center of mass is going with uniform velocity. Velocity of center of mass constant, acceleration of center of mass is constant. Here it is so, because there is no external force horizontally and there is vertically external forces, but they balance mg normal reactions and other contact forces. So because center of mass is moving with constant velocity, then loss in kinetic energy equals to Ke initial minus Ke final will be half of m star into u relative square minus v relative square, where m star is called reduced mass. I have written the formula here, m1 m2 upon m1 plus m2. So this formula is very important. I have used it and I have explained it elaborately in other videos. If you are, I hope you are supposed to know it very well. If you are not sure about it, please go back to the other videos and have a look at it. Right. So here u relative, that is relative velocity initially will be only u because the cart was having 0 velocity, and finally when it comes to the rear end it is supposed to have relative velocity 0, that is what they had mentioned. So loss in kinetic energy will be this much, and here the entire motion is only horizontally, so there is no vertical movement, there is no change in gravitational potential energy, there is no other form of potential energy or kinetic energy, other form of energy except the kinetic energy translational of these two. So by combining the first equation and second equation, here we got loss in mechanical energy, and the loss in mechanical energy will be only loss in kinetic energy, that is all, there is no other form of energy here. So by combining both of them or by comparing both of them, so you see that the 20 joules has to be equal to this much, half of m star is this, m into capital M by m plus m, 2 into 8 by 10, 1.6 into u square if you substitute there. So 1.6 is written as 16 by 10, and 10 into 2 20, 20 into 20 400, 400 by 16 square root, you will get 400 by 16 is what, 20 by 4, which is 5, yeah, 5 meter per second is the velocity there. Okay. So beautiful concept we have used, two concepts are applied, very useful, very standard results. Now elastic collision, one small idea, whenever you have elastic collision, speed of approach, relative speed of approach before collision equal to relative speed of separation after collision. So relative velocity magnitude is not affected by elastic collision, direction is reversed, okay, but magnitude is not affected by elastic collision there, okay. So magnitude of relative velocity will be changed only because of kinetic friction here. Now let us try to find the time taken. Now the total motion that can be visualized into two stages. Stage 1 is when you have relative motion towards right, and stage 2 is after the elastic collision, where the relative velocity will be in backward direction. With respect to Planck I am looking at it. So when relative velocity is right side, friction will be left side on the block, and of course action to reaction on the Planck will be right side, and so you have the corresponding accelerations, and similarly here also you have the accelerations. And if you observe carefully, relative acceleration in both the cases would be a1 minus of minus a2, a1 plus a2 opposite to relative velocity. So that means minus of a1 plus a2 is going to be the relative acceleration in both the cases, opposite to relative velocity. And a1 equal to friction by mass of the block, mu mg by small m will give you mu g, a2 equal to friction by capital M, which is mu small mg by capital M, which is mu g by 4. So a relative equal to minus of a1 plus a2, which is going to be minus of 5 by 4 mu g, a relative we got it. And here if you observe it totally, v relative equal to u relative, I think there is some small corrections, extra printing happened, I will remove that part. So yeah, so v relative equal to u relative plus a relative into t, and I can write it as v relative equal to 0 there. So actually the motion is reversing, but throughout the motion if you observe it, a relative is opposite to v relative, and v relative is changed only because of the a relative, not because of the collision anyway in terms of the magnitude. So instead of taking back and forth, you can take to be totally in one direction only, then also it does not matter, traveling totally 2L distance there, alright. So that way I can use this relation, v relative equal to u relative plus a relative into t, where v relative is 0 finally after traveling 2L distance, u relative is known to you 5 only, a relative we have just calculated minus 5 mu g by 4. If you substitute there, I think this is where we have got it, it got shifted I think, okay, 5 mu g by 4, this is where you get it. So now you can calculate it and see what you get. Mu is 0.5, mu into g is going to be 5, 5 into 5 is 25, by again u is 5, so 5 gets cancelled, 4 by 5 you will get, which is 0.8 seconds. So that is answer, that is fine. So beautiful three concepts we have used, proper one, and I am sure everybody understood it, and these concepts cannot be missed by any aspirant who is seriously preparing for IIT JEE mains and also advanced. For advanced especially, it is very useful concept. So with that I will conclude here. Thank you very much for your time. Until next time, goodbye.